Yep, this one is going to take an extra cup of coffee, aka part 1. We're going to divide this next topic of sketch curve into at least 3 parts. Today we're going to hit part 1. So I think the way we're going to handle this is we're going to start off with a big picture explanation. After that, we're going to break it into pieces and we're going to take notes. So today, this topic today is going to be heavy on the old note taking. So bear with me while I'm going to talk about everything and then we're going to go back and write things down. So I just want you to listen for now. So let's look at this function we've got right here. And let's just start. I don't know what f of x is here. I don't know the actual function. I just know that it's this shape. It's this blue thing. So let's talk about what we know. We know that we've got 3 x-intercepts here, right? We have x-intercepts and they are in red. We also know that we've got what we now call a max and a min here, right? So we've got a minimum and a max. I put those in green. We know that we've got some increasing slope in different places. So like this is increasing right here. This is increasing slope, right? So we've got some increasing. I put that in green too. We've got some decreasing slope. I'm going to put that in yellow. So we've got some decreasing slope. We know that, right? Not new information. And what else do we have? We've got a y-intercept. Okay, here's a y-intercept. That's good. I'll put that in red because it's an intercept just like an x-intercept. All right, so these are the major players in the game. Nothing groundbreaking here. We've looked at all of this. So what's interesting about these 3 pieces? Our y-intercept, our x-intercept, and our max and min are now going to fall under a new umbrella called critical points. Critical points. So these blue parts, these things I highlighted in blue. So where's my blue? Here, and here. Those are all what we call critical points. A critical point is anything important on a graph. We are going to, in this unit, focus on critical points. This is not all the critical points. We're going to learn more about them in part 2, but that's what we're going with. So our objective right now, wow, you can't read that at all. Our objective is going to be to find critical points, and I'm not writing that out ever again, to find critical points and sketch graphs, okay? And the reason we talk about sketching is because these are going to be rough sketches. We're not going to do overly precise stuff. It's going to be fairly rough. Things are not going to be symmetrical. Basically, it's my kind of graphing. Terrible. Rough sketches. Okay, so that being said, let's take one more look at this little list we've got. Where do y-intercepts come from? What store do I go to buy a y-intercept? I go to an original function store, right? Where do I buy x-intercepts? I buy those at an original function store. Where did we learn we buy max and mins? We buy those at the first derivative store, correct? Increasing, decreasing, also from the first derivative. And that's it. We're not going to go any further than that today. So today we're going to just really focus on these 5 valuable pieces of information. And that all stems from original function, first derivative, and first derivative. Okay, so let's take a look. Our new word, let's write this down. Our new word are critical points. So critical points. Critical points are exactly what they say. They are points that are very important on a graph. So they're going to be x-intercepts, y-intercepts, maximums, minimums, and then the one we're not going to talk about today, but we will eventually talk about, are called inflection points. But we're not going to talk about this today. Not today, but we will tomorrow. Okay, so these are what we're going to focus on today. So these are critical points. They are points where the graphs in some way, shape, or form are doing something important, and they usually have to do with setting a function equal to 0. Okay, so let's look at something else we know. We know that when we've talked about previously about places of increasing intervals and decreasing intervals, right? We've talked about increasing and decreasing. Oops, that's not how you spell intervals. Intervals. Okay, when is a graph increasing? A graph is increasing when it has a positive slope, right? A positive slope. And it's decreasing when it has a negative slope, okay? We saw before that an increasing slope occurs when the derivative is greater than 0. So remember what that meant is that meant that we plugged in a value for x, and if we got a positive number, then we had an increasing slope. Vice versa, a decreasing slope is when the derivative is less than 0. Okay, so these are also notes that we want to make sure we've written down. So if we look at this terrible graph I just drew, our increasing intervals are right here, right? Isn't this when we have an increasing interval, that green area? And we have a decreasing interval right here in the middle, and that's where we've got a negative slope, and we can find that algebraically because our derivative would be less than 0. Okay, so the reason max and minimums are really important is because they separate intervals. So here's my max right here. It's at the very top, and it's in between the green and the red. It's in between the increasing and decreasing. It's when the interval changes. Same with the minimum. They're important because they mark change. You go either from increasing to decreasing, or you go from decreasing to increasing, right? And if you're going from decreasing to increasing, then that's your minimum. And if you're going from increasing to decreasing, then that's your maximum, right? And that occurs when our derivative equals 0. So we have looked at this before, but just to refresh your memory, what if we look at something like this? What if I tell you that f of x is 1 minus 5x plus 4x squared? All right, I can use this. This is my original function, And I can use this to find my x-intercepts, my y-intercepts, and then I'm also going to use this to find any y values, okay? Any y value. If I take the derivative of this, I'm going to get negative 5 plus 8x, right? Isn't that my derivative? All right, so depending on what I'm looking for, I can find any from this first derivative. So if we would like to use this first derivative, and if we're looking for increasing or decreasing, we're going to take our first derivative and we're going to set it either greater than 0 or less than 0. You can use an inequality. So you can find increasing by saying negative 5 plus 8x is greater than 0, right? So if I do that, this will tell me all the places, the whole area where my graph is increasing. Just the same, we can use decreasing. We can find the decreasing interval by making this less than 0. And then solving, right? We can figure out our places for intervals, okay? So we can find intervals with inequalities. Okay, so that's, I would call that real important. We can find intervals by using inequalities of our first derivative. Okay, should I write that down? Find intervals with inequalities of the first derivative. Okay, so that's an option. We can also use this to find critical points. So let's say I would like you to find, critical points. Okay. In this case, you are going to take negative 5 plus 8x, and that's going to equal 0. And in this case, our critical point is our max and our min. Okay? So if we're looking for a critical point, we set it equal to 0. And if I do that, then I have 8x equals 5, x equals 5/8. Okay? So I know that I have a critical point at 5/8. I don't know what kind of critical point it is. I just know it's a critical point. So now that I've found a critical point, I'm going to put it on a sign chart. We've looked at sign charts before. So if I put my 5/8 on a sign chart, I can then test either side. So let's say I'm going to choose 0 as a test point, and I'm going to choose 1 as a test point, and I'm going to plug them into my first derivative. So I'm going to say negative 5 plus nothing is negative, right? So that means I've got a decreasing slope. And if I plug my 1 in here, I'm going to have negative 5 plus 8, which is 3. That's positive. So I'm going to have a positive slope. Now, if I had done that with my inequality over here, I would have said, I'm going to come over here and I'm going to finish solving this. If I had finished solving that, I would have 8x is greater than 5, x is greater than 5/8. So wherever x is greater than 5/8 is going to be increasing. And then sure enough, what do I find over here? Greater than 5/8 is increasing. These two things gave me the exact same information. If I did that with my inequality right here, I would have found that 8x is less than 5 and x is less than 5/8 is my decreasing, which is exactly what I found. So there's two ways to kind of get this part. We've got the increasing and the decreasing interval that we found setting up an inequality, or over here, we set it equal to 0, found our critical point, and then created a sign chart with test points on either side, and that led us to the same point. So let's consider what we've got one more time. Okay, so we've got our critical point at 5/8, an increasing interval from 5/8 to infinity, and decreasing from negative infinity to 5/8. Now, this critical point is at 5/8, but if we want to know the coordinate, if we need a coordinate for this, then where are we going to find that? We have to go, oh, look at this. Y values come from original functions. So that means we're going to take our original function and we are going to put this 5/8 in for x. And that's going to give us the y value of it. And I don't know why I picked such ugly numbers. And it's, I think, basically negative 0.5, which means that our critical point is at 5/8, wow, 5/8 negative 0.5. And I know that it's a minimum. And I know it's a minimum because it was decreasing to increasing, which is what makes it a minimum. See right here, we'd written that down. Decreasing that changes to increasing is a minimum. So we know this is a minimum because we had it going down into it. Okay, let's do a whole problem from top to bottom. Okay, let's say we have f of x equals x cubed plus 6x squared plus 9x plus 2. And you have been asked to find critical points. Okay, so you've been asked to find critical points. All right. And when I say critical points, I mean max and mins. Okay, so the first thing we're going to do is take the derivative. So we're going to take this derivative and we're going to get 3x squared plus 12x plus 9. Okay, now the critical point happens when the derivative equals 0. So 0 equals 3x squared plus 12x plus 9. This is quadratic. So I am going to factor this. 3 times 9 is 27. 9 and 3 add to 12, so this is good. Okay, so that's going to give me, let's see. Oh, I'm going to factor out a 3. Okay, x squared plus 4x plus 3. I'm going to factor that even further, and I'm going to get x plus 3 times x plus 1. Yes, okay. And then I'm going to find that my x equals negative 3 and x equals negative 1. Okay, so this is the beginning of my critical points. Now, I need to plug them into my original function to find out their y value. So if I do that, back to the original function, I'm going to say f of negative 3. So negative 3 cubed plus 6 times negative 3 squared plus 9 times negative 3 plus 2 is like negative 70. Okay, so that means I have a critical point at negative 3, negative 70. If I do that with my 1, then I'm going to say f of negative 1, and I'm going to do the exact same thing, and I get negative 2, I think. Or 2, I think it's negative 2. Okay, but now we have to decide if these are in maxes or mins. So to do that, I'm going to come put my negative 3 here, and I'm going to put my negative 1 here, right? And I got those numbers from this, right? The x values. I'm going to choose test points in between. So I'm going to pick like, oh, I don't know, negative 4, negative 2, and 0. And I'm going to plug those into the derivative, not the original function. The original function would give me coordinates. I don't want coordinates. I want to know about the slope. So I need to know positive or negative. So if I take my negative 4 test point and I plug it in here, I'm going to get, let's see, a positive number. I think it's going to be 9. Okay, and if I plug my negative 2 into my derivative, I'm going to get negative 2 squared is 4 times 3 is 12. 12 minus 24 plus 9. Ooh, I think that's going to be negative. Okay, so I get negative. And then over here, I'm going to take my final test point, 0. I'm going to plug it in. So I'm going to get 0 plus 9. So that's positive again. So what that means is that this is going to be headed up, and then it's going to be headed down because it's negative, and then heading back up. So therefore, my negative 3 critical point is going to be a max. My negative 1 is going to be a minimum. All right? We can add all of that information to a graph. And that's going to kind of be where we're, like, our ultimate goal here is going to be putting this stuff on graphs. So if we do that, we know that we've got over at negative 3, minus 70 or whatever crazy number that was. We've got something down here, and we've got something here, right? And we know that in some way, shape, or form, we're decreasing coming into that, increasing going up, and then decreasing again. Now, I don't know my x-intercepts at this point. I don't know my y-intercept, but I'm starting to be able to build my graph. The graph is going to get more detailed as we go, but for right now, this is step 1, and this is our goal of what this should look like. So, recap. Critical points are maximums, minimums, inflection points, intercepts. They are found by taking the first derivative and setting it equal to 0. To find the y value, the coordinate, you plug them into the original function. But to find the max and the min, we set up a sign chart, we choose test points, we plug those test points into the derivative, and if they're positive, it's increasing, and if it's negative, they're decreasing. A maximum occurs when you go from increasing to decreasing. A minimum occurs when you go from decreasing to increasing, okay? The last piece I want to point out is that there is a difference between local max and absolute max. So local max and then absolute, sometimes you'll refer to that as global. Sometimes this is relative, called relative. So these are types of max and mins. They can be the words we're going to use will be local and absolute, but global is very common. So when that occurs, that's when you've got more than one of each. So if you've got something like this would be, so we've got two maximums here, a big one and a smaller one. So this would be your absolute and this would be your local because it's smaller. In this case, for the minimums, there's only one. So this could be your absolute and your local all at the same time. And furthermore, it's possible to have none. You could have something that looks like this, and this has none. It doesn't have a max or a min, even though it's increasing. So there's options out there. Okay, that's enough for today. All right, bye.